When we are given two triangles and we're told that they are similar, that means two things. The first thing it means is that all the corresponding angles are congruent. Well, there's a couple of words in here we need to make sure we understand. Corresponding just means you can see these triangles have the same shape, different sizes, and this angle corresponds to this angle. This angle corresponds to this angle, and this one corresponds to this one. So you can see how they're related to each other that way, but they're also congruent, meaning that this angle is 90 degrees and this angle is 90 degrees. They're equal to each other. This angle is equal to this angle, or congruent. This angle is equal to this angle. Okay, so that's the number one thing. And number two, the ratios of the corresponding sides are equal. Now, what does that mean? Again, not only do we have these corresponding angles, we have corresponding sides. And this side is between this angle and this angle, so it's related to this side, which is between the same two angles. Okay, so those are corresponding sides, and the ratios of those sides are equal. And that means, so I've got this is 3 units, this is 6 units. What do I need to multiply by to get to 6? I'm going to multiply by 2. Again, that's a scale factor, right? But it's also the same here. If I'm multiplying this one by 2 to get its corresponding side, I can multiply this one by 2 to get its corresponding side. So 4 times 2 is 8. The same here. I can multiply 5 by 2 and I will get 10. Let's go ahead and write that in there. So we know that that's 10. Now that we understand what it means to have similar triangles, now we can go on and see how we can use ratios to solve for this 10. Okay, so I'm going to set up some information here. We know that this side corresponds to this side. So I'm going to set up that notation, if you will. So I'm going to say AB, the line segment AB corresponds to the line segment DE. Okay? And now I don't need to work with this. It's not necessary in this problem. I could have started with this one and not use this one right here. It doesn't matter. But I only need one side that I know, and then I'm going to do the side that I don't know. Okay, so I'm going to set up the relationship between these two now. And notice I started with the larger triangle. I'm going to write that down too. Let's see. This is the larger. This is the smaller. Okay. Okay, now let's write this one down, this relationship. So I've got AC, the line segment AC corresponds to the line segment DF. Okay? And again, this is my larger, from my larger triangle, and this is from my smaller triangle. And this is important to keep everything in order when you're setting up these proportions. So now I can set up the proportion. Let us write out beside each one of these what each of these are equal to. Let's do this color. So let's do that one. So AB, line segment AB is 6, and line segment DE is 3. Okay, that's this one and this one. And then line segment AC is our unknown, so I'm going to call it X. And then line segment DF is 5. That's the hardest part right there, is just setting these up. And now I can set up a proportion. So I'm going to say, I'm just going to start with my larger to larger, and then I'm going to do smaller to smaller. So I'm going to say 6 is to X as 3 is to 5. Okay? To solve for x, I need to get this in the numerator. So I'm going to multiply both sides by x. And I get x goes into x one time. So I'm left with 6 is equal to 3 over 5 times x. Now I need x by itself. So I'm going to multiply both sides by 5 over 3. 5 goes into 5 one time. 3 goes into 3 one time. So I'm left with x on this side and 5 over 3 here. 5 times 6 is 30 divided by 3. And 3 goes into 30 10 times. Okay? And that is what we got initially. Right? So that worked out. Now I want to show you, you can set this up multiple different ways. And I just want to show you that there are other options. Like if you don't want the x in the denominator when you're starting, then we can set it up the opposite way. So I'm going to go this to this and this to this. So we're going to go x is to 6 as 5 is to 3. Now notice when I go x is to 6, I'm going from the bottom to the top here, and I go from the bottom to the top in the other one. So basically smaller to smaller and larger to larger. Okay? If we get them mixed up, it won't work. So now I can multiply both sides by 6. 6 goes into 6 one time, and I get x equals to 30 over 3. So x again is equal to 10. Okay? I'm going to show you even a third way to do this. I'm going to go from here to here and here to here. Just to show you, as long as you maintain the connection. So I'm going to go 6 is to 3 as, let's see, x is to 5. 6 is to 3 as x is to 5. So now I'm going to multiply both sides by 5. And I get 5 goes into 5 one time, and I'm left with x here. 5 times 6 is 30, again divided by 3. 3 goes into 30 10 times. X is 10. And there are other ways you can set this up as well. And why am I doing this? I'm doing it so that you know maybe your fellow classmate sees it one way and you see it a different way. It doesn't matter as long as you're really careful with how you set this whole thing up. Okay? So I encourage you to do this first whenever you're setting up proportions, and then label each of the values. And then that makes it really easy to set up each of these proportions, okay? And just know, if you want your x in the numerator, that you'll need to set it up where you're doing that first, like we did in these two. Okay? I sure hope this helps, and I will see you in the next one.